Okay. Oh, good. Okay. Can you guys hear me? Somebody unmute and tell me. Okay. Just give me, I'm sorry for all of this. Okay. Okay. Sorry, trying to get my microphone working. Can you hear me? Yes. Okay. I seem to be having all sorts of technical difficulties this morning. It generated a new meeting ID for some reason or another. But in any case, hi, everybody that is here. Let's see how many we've got. We've got 7 of you in the room. That's good. We'll probably have more people coming in as they see my email. I hope that you're all right. Remember, you have a test on Friday. That test is only on the nervous system. That's it. Okay, that's on the chapter that we've completed already. It does not include today's work. Today we're going to be talking a bit about the special senses. First of all, there's lots and lots of, we've got lots of nerves that are dedicated to sensing things all over our body. We have nerve endings which receive information about touch, about pressure, heat, cold, pain, all sorts of things. Not only of the surface, but in the interior, all of these kind of senses all over the place. But the special senses are those which are isolated to particular organs, which are dedicated to one particular purpose, to forming one particular sensation. So there are specialized senses which respond to light, to taste and odor, to sound, and to motion. And we're going to talk mainly about those concerned with sight, and then with hearing and motion, to our eyes, to the retina of our eyes. In fact, we're going to find out the retina is actually like an extension of the central nervous system. And the cells which perceive light are very, very highly specialized. And we're going to see that there are several kinds of them. The sense of smell and of taste are very closely linked in the mouth and the nose. We're not going to talk much about them. We'll mention them at the end. We're not going to talk much about it. Unfortunately, in human beings, the sense of smell and taste is highly reduced compared to have a very highly developed sense of smell, nor of taste compared to even to mammals like the dog, for example, which have very, very highly developed sense of smell. In fact, it's been said that dogs actually see their world through smell, the other way around. We depend much more heavily upon sight to develop a sense of the world around us. The next the organ that we need to think about is the ear. And the ear has 2 major functions. The first, obviously, is there's one part of the ear which is dedicated to hearing and has specialized nerve endings which do that. There is another part of the ear, however, which is concerned with motion. And that part of the ear closely cooperates to maintain posture, to maintain balance, and to give us a sense of motion. a sense of how we are moving in the world. Now, just thinking about the eye and then the ear, what those organs are doing is they're of the world around us, of our environment. And even if you close your eyes, you can actually have a sense of the room around you, of the space around you through your ears. Close your ears and you have a very good sense of eyes. And this is something that's a little bit strange, and that is that we have these nerve endings which are perceiving these things. They are perceiving light in the retina of the eye, and they're perceiving sound in the ear. Endings are being stimulated, and they are sending those messages to the brain for interpretation. You actually see and you actually hear in your brain. That is where the pictures that are coming in are constructed, but you don't perceive that. You don't perceive what you see around you in the back of your brain, which is actually where you're seeing it. You see it outside. You see it outside you. And this is because the brain relays that information back, a projection of sensation. But it's actually a trick that the brain is performing, that we look around us and we think our eyes are seeing. In a way, they are. They're owned, but they have no way, the eye has no way to interpret what it's seeing. It's just for that sensation to be comprehensible, it has to be relayed back into the brain, and the brain reconstructs the outside world from that information coming in. By the way, the brain is easily tricked. This is why these all the time. Those all depend on the fact that the brain is attempting to interpret with limited information all the time. And the brain can make mistakes in its interpretations. So let's have a look at the actual structures of the eye. A lot of this will be familiar to you, especially the outside, but maybe not the internal anatomy so much. We're going to consider it in relatively simple terms. Just think about the outside of your eye. This is all familiar to you. You have an eyeball staring out at you. It has a spherical nature. It's not entirely spherical, but it has a spherical nature. It's a globe. And we only see part of that globe between the eyelids here. The eyelids are invested with an attempt to catch dust and this sort of thing before it lands in the eye. Because the surface of the eye is covered with a very, very thin layer of tissue called the conjunctiva. It covers the whole of the outside of the very richly invested with nerve endings. It can sense touch, it can sense pain, and it responds very, very quickly to those sensations. And the immediate response, if you touch the conjunctiva, you have a reflex response to blink, to close. We have a blink reflex that operates the whole time. And it is picking up sensations from the eyeball of drying or of irritation or anything like that. But it keeps we keep blinking for a specific reason that I'll explain in a minute. Here is called the sclera. And the sclera actually extends all the way back. It is one of the major coats, major tissue layers that make up the eyeball. But in the very front, the sclera is completely clear. It is transparent, called the cornea. That is the cornea in front. But when we're just looking at the eye and not considering its internal anatomy, what we see is on the inside here, this is the iris of the eye. A very, very, very complicated muscular structure with two opposing, one that drags it open like a curtain. We'll talk about this again in a minute. But the this is the pupil of the eye. What appears as a hole in the middle, in the center of the iris, that is the pupil, and it's the response to regulate the size of that pupil. And the pupil will increase in size if the light is dim, or if you're looking at something far away. If you're looking at something close by, the iris will close to make this almost a pin same response in very bright light. So the iris is doing two things. The first thing is it's regulating the amount of light coming into the eye. That's one. But the other is it participates in the formation of an image. It is actually part of the seeing apparatus of the eye. The cornea, the clear part of the sclera, the iris on the inside, and then the pupil of the eye there. If we look, if we were to flip the eyelid back and look, we'd find that up in the corner of the eye, on the outside of your eye, there is a large gland, which is the tear gland. It's called the lacrimal, L-A-C-R-I-M-A-L, the lacrimal gland. And it's situated here. It continually secretes tears. And in fact, it secretes tears in response to the eye. As a sensation comes to your eye that it's starting to dry, we blink, and that stimulates release of tears by the lacrimal gland onto the eyeball. So the first thing is that the tears are lubricating. They are lubricating the eye. But there's something else as well, and that is that situated throughout our eyelids, especially the upper eyelids, but also on the bottom eyelids, there are fewer, but there are several oil glands on this eyelid here and down here. Those glands release oil into the tears. They release a lipid into your tears, which has a very important lubricating function, especially for the cornea. I mention this because there's currently an absolute epidemic worldwide where people are developing a condition where the front of the eye actually starts to dry out. And it's related to the fact very strongly that we are staring at screens so much. And for some peculiar reason, even if you're looking at a movie screen or it reduces our blink reflex. We tend to sit with our eye open much longer. It suppresses the blink reflex and our eyes dry out. Not only do you not lubricate with tears because you're not blinking, but you're not lubricating with the oils either, and in addition to clog up. So there are two things to remember, especially if you use your computer a lot. First is every 20 minutes, stop and give your eyes a rest. Stand up, walk away and blink. Make sure, and whenever you can while you're working, remember to blink. One very useful trick is to apply a warm face cloth to your eyes when you shower or wherever, because that can melt out the oils. The oil tends to set inside these glands if you don't blink often enough. It's really not only because of their lubrication qualities, but also because they contain substances which are antibacterial. There's a substance released by the lacrimal glands into your tears called lysozyme. In a minute, we'll go through, so you don't have to worry about all of the spellings and everything. But the lysozyme is an antibacterial agent, actually kills bacteria. So your tears are disinfectant as well as being a lubricant. Tears are really important. You continually produce of the eye here. That little patch of tissue is called the caruncle, and it marks the place where there are ducts leading out of your eye, and your tears drain out here. They're collected in a little tube here, almost here at the side, and then they drain down into your nose. So they're drained in, your tears are continually drained into your nose from the eyes. Okay, is there anything else I need for this? Sorry, I don't think so. Let me just check. I have. Okay, now let's have a look at the structure, the internal structure of the eyeball. Some of this you've already heard about. Here is the white of the eye that you see in between the eyelids. Here's cornea here, sclera here. The sclera persists all the way around. It forms this thick, fibrous, strong globe structure that gives the eyeball its structure. Of course, it has to be clear in front because the light has to feature here as well on the cornea. And that is that the cornea has no blood vessels. There are plenty of blood vessels in the rest of the eye, but there are no blood vessels here in the cornea because that would impede passage of light, but you'd also probably be seeing blood vessels if desirable. So there's the sclera, then the cornea, and then behind this, there is a layer called the choroid. And the choroid is very complicated. In the back here, all the way around, the choroid, it forms a tissue layer, which is very, very dark. It's almost pitch, it's a purplish black color, and it's behind the eye here. The purpose of the choroid is to absorb light so that you don't get light reflecting all the way around inside the eyeball. Once light is passed by this dark choroid at the back. But at the front, the choroid forms very intricate muscular systems, which we'll discuss in a minute. And it also forms the iris here. So we can see there's if you think about it this way, here's the iris here, and that together they describe a sort of a chamber. And that is called the anterior chamber. And it is filled with a fluid, a clear fluid, which continually is secreted and then is drained away. Remember the names, but there are little canals here and here that continually drain this fluid from the anterior chamber. So for the anterior chamber, it's very liquid. It's an aqueous solution, almost like tears that fill that. The eye behind the iris, we have a system which we call the posterior chamber. The whole of the back is the posterior chamber. And the posterior chamber is largely filled with a gel. It's a jelly-like substance called the vitreous body. It's completely, you get little particles of cells, occasional blood corpuscles or whatever, drifting through the vitreous body. And when that happens, those little bits of detritus cast a shadow on the retina, which is the sieve as a floater. You know, when you suddenly you see this thing coming into your field of vision, you can never keep it in your vision because every time you try to look at it, you move it. It gradually will drift out of sight. That is something drifting through the vitreous body. Chamber, then behind the iris, we have the posterior chamber. And we immediately notice that but right behind, here's the iris with the pupil here, and right behind the iris is the lens of the eye. Under normal circumstances, it's a lens shape, and it's at the corner of the lens here, there are ligaments which attach it to these muscles that are associated with the choroid. They're called the ciliary muscles. And the ciliary muscles, when they contract, can pull the lens flat. The lens simply bounces back. It's like a spring, bounces back into its normal round shape. Ciliary muscles contract, it pulls it flat. And this allows the lens to perform accommodation. It begins to modify the focus of of the image that's coming through it. So we have the choroid, and lying in front of the choroid, a very thin layer. Here's its boundary here. A very thin layer all the way around at the back of the eye called the retina. And the retina is the light perceiving part of the sensory nerves lie that are going to perceive light and send messages to the brain for interpretation. You'll realize, first of all of these nerves are going to be sending messages off to the brain, and they send it through this. It leaves the eye not right behind where the lens in a line with the lens, but at an angle, because there's no perception of sight at where the optic nerve leaves. And we actually call that the blind. And you can actually demonstrate you can find your own blind spot if there's a little exercise in your book. I'll show you here. This exercise here, if you perform that, you can actually demonstrate to your own satisfaction that you do indeed have a blind spot. If part of your eye, you can't see it. It disappears. But right opposite the lens on the retina, right opposite the lens there is a point where the most acute focus of an image, part of the retina called the fovea. And surrounding the fovea, there is an area of, which is actually, we'll see in a minute, has a yellowish kind of pigment. It's a circular area where the most acute interpretation area, where we have the most retinal cells. It's also the area where we concentrate almost all of the cells of the retina which can see color. And this area of intense vision, you can think of it that way, is called the macula. As you move, you can still form images away from it, but you tend to see them in shades of gray because there are no color perceiving cells away from the macula. And these are the areas of peripheral vision. The macula view tends to fall most in clearest focus and with the greatest analysis right here. Away from that is peripheral vision, and it is interpreted mainly by cells which only see in terms of black and white. Here's the optic nerve leaving there. Now, the eye on the outside of the cells, which are anchored to the eyeball itself and then to your orbit, and those are the muscles which move the eyeball, swivel it, move it up and down, and around. Those are called the extrinsic muscles because they're outside the eyeball. These here, the ciliary muscles, inside the eyeball. So, okay, let's just go through here. We'll just revise this for a minute. Use this list, especially in your revision, but let's get them straight in our minds now. What were the lacrimal glands? Tears. Major lacrimal glands are situated on the side of your orbit here. There are one or two other smaller lacrimal glands as well, but it's the bulk of your tears are produced by the major lacrimal glands. The tears are lubricating, but they contain lysozyme. That is one of the disinfectant substances that kills bacteria. The whole of the eye, the outside of the eye, is covered with a thin layer of epidermis called the conjunctiva. Most of the conjunctiva rich in blood vessels, excepting where it covers, but the conjunctiva also contains many pain and touch receptors. And that any stimulation of the conjunctiva will cause you to blink. And the conjunctiva are continually sending information to the brain. It starts to dry out, and that causes the lacrimal glands to produce tears. The sclera is the thick connective tissue that forms the body of the eyeball, and it's opaque white tissue, excepting at the front where it is clear, and there it forms the cornea of the eyeball. It lies next to the sclera, and at the back of the eye especially, it is I wouldn't say pitch black, it's a very dark purple-black color, but it's highly absorptive, and it absorbs any light that has not been absorbed, perceived light. The choroid stops light from bouncing around, reflecting inside, and causing false images and things like that. The iris and the pupil have two responsibilities. One is to regulate the amount of light coming into the eye, and two is the act of the image. The fovea is the point of focus right opposite the lens, and it's surrounded by an area densely invested with nerve endings where all the color perception is performed, and that is called the macula. All of those sensory cells of the retina, all of them combine and leave the eyeball at the optic nerve, and we'll trace where that goes next time, because I think I'm going to open it up. We've just got like 10 minutes or so. If you have any questions that you want to ask me to the upcoming test. Oh, wait, we're going to have we'll leave this up as our screensaver, because I think this is so beautiful. Now, this is the iris, but look how it has circular muscles, which are called sphincter muscles, which close it. And then these muscles drag the pupil open, rather like a curtain. Okay, if you have questions, feel free to unmute yourselves, and then yeah, you can go ahead and just ask me. Okay, if nobody has any questions, then you feel free to. And then well, this is stuff we'll do next time, but I just want to point you to this. You might want to actually you've got a couple of minutes left in the class. Why don't you use that time to actually watch one year on how we perceive color? And that'll set you up for what we'll discuss in our next class, not Friday, obviously, but on the Monday. We're also going to, if you want to read ahead, we're mainly going to do the ear after we discuss. At that point, then I'd advise that you watch these other movies. If nobody has any questions, I'll bid you all farewell. Did you want to ask something? No? Nobody? All right.